Every single day, across the United States, millions of tons of wood quietly disappear. Broken pallets, storm-damaged trees, construction waste, old lumber, sawmill scraps. They don't rot endlessly in landfills. They don't pile up forever. Instead, they are pulled into one of the largest and least visible industrial systems in the country. A system that turns discarded wood into fuel, power, heat, and raw material for entire industries. Here's what very few people realize. In the United States alone, hundreds of millions of tons of waste wood are collected, processed, and transformed every year, feeding biomass plants, paper mills, energy facilities, and manufacturing networks that never stop running. Today, we're stepping inside America's massive wood chipping and biomass plants, where mountains of discarded wood are reduced, sorted, and transformed into usable energy and industrial material. Before we begin, don't forget to like, subscribe, and turn on notifications so you never miss our deep dives into the hidden systems that keep the modern world running. Wood feels natural, simple, renewable, but industrial wood waste is anything but small. Every year, the United States generates enormous volumes of wood waste from construction and demolition, pallet and packaging industries, forestry operations, storm cleanup, manufacturing byproducts. Without a system designed to process it, this wood would overwhelm landfills and release massive amounts of methane as it slowly decomposes. Instead, it is redirected into a tightly controlled industrial pipeline, and that pipeline begins at scale. At large wood chipping facilities, trucks arrive continuously. Flatbeds, walking floor trailers, dump trucks, each carrying tons of wood, stacked, broken, irregular, and unpredictable. The piles grow quickly. In some facilities, wood stacks reach 20 to 30 feet high, stretching across acres of land. From above, the site looks less like a factory and more like a forest made of leftovers. Excavators and wheel loaders move slowly and deliberately, feeding the system. Nothing here is rushed, because once the machines start, they never stop. At the heart of the plant sits the wood chipper. These machines are enormous. Some are the size of small buildings. As whole logs, pallets, and scrap wood are fed inside, spinning steel knives tear them apart. The sound is constant, deep, relentless. Wood enters as chaos, different sizes, shapes, and conditions. It exits as uniform chips. This uniformity is critical. Biomass systems depend on consistency. Too large and combustion becomes inefficient. Too fine and airflow is disrupted. Sensors continuously monitor chip size, feed rate, and machine load. The goal is simple: turn randomness into order. Much of the incoming wood contains metal, nails, bolts, brackets, fasteners. Before the chips can move further, they pass beneath powerful magnetic separators. Steel is pulled out instantly. Collected metal drops into bins to be recycled separately. Nothing is wasted. What remains is clean, consistent wood, ready for its next transformation. Not all wood chips are equal. After chipping, material flows onto massive vibrating screens. These screens sort chips by size. Oversized pieces are sent back for reprocessing. Fine material moves forward. This loop continues until the output meets exact specifications. Some plants process hundreds of tons of wood per hour, operating day and night. The system is designed to correct itself automatically. No shouting, no panic, just constant adjustment. Once sorted, wood chips are directed to different destinations. Some are stored in massive outdoor piles, waiting to be shipped. Others move directly into enclosed silos or conveyor systems. From here, wood chips may be used for biomass power generation, industrial boilers, paper and pulp production, wood pellet manufacturing, animal bedding, landscaping materials. Each application requires a different specification. Each specification is tracked. Each pile is measured, labeled, and managed. Paper and pen. At biomass energy facilities, wood chips become fuel. Conveyors feed chips into boilers the size of multi-story buildings. Inside, controlled combustion produces heat. That heat creates steam. Steam turns turbines. Turbines generate electricity. From the outside, the plant appears quiet. From the inside, everything is in motion. Pressure, temperature, flow, all monitored continuously. Many biomass plants supply power to thousands of homes, using fuel that would otherwise be discarded. Modern wood processing plants are highly automated. Operators work from control rooms filled with screens displaying live data, feed rates, moisture levels, chip size distribution, energy output, emissions data. Adjustments happen in real time. If moisture rises, combustion changes. If chip size shifts, conveyors slow. If a sensor trips, the system isolates the issue. The goal is not speed. The goal is stability. Wood chipping and biomass plants are not built for spectacle. They exist because they solve multiple problems at once: waste reduction, energy production, material reuse, cost efficiency. In many cases, using waste wood as fuel reduces overall environmental impact compared to fossil fuels, especially when paired with modern emissions controls. This system doesn't ask for attention, it simply works. Despite the scale, people are everywhere. Equipment operators, maintenance crews, control room technicians, safety inspectors. They wear helmets, high-visibility vests, and hearing protection. They don't pose for cameras. They move with routine. Because this system runs every day, whether anyone is watching or not. Wood enters broken and unwanted. It leaves as energy, heat, and industrial material. Nothing flashy, nothing dramatic. Just a cycle, repeating endlessly. While cities sleep, machines keep turning. While forests regrow, waste wood finds a second purpose. While lights stay on, fuel quietly disappears into the system. Most people never see these plants. They drive past them without noticing. But without them, modern waste management, energy production, and manufacturing would look very different. This is not a story about wood. It's a story about systems. Systems that take what society throws away and turn it into something useful again. Quietly, relentlessly, at scale. If you enjoyed this journey inside America's massive wood chipping and biomass plants, make sure to like, subscribe, and turn on notifications for more deep dives into the unseen systems that keep our modern world running. Thanks for watching, and as always, stay curious. With more than 2 billion pallets in circulation and over 500 million new pallets produced every year, pallets are the quiet backbone of the modern economy. But here's the part very few people know. In the United States, over 90% of all wooden pallets are reused, repaired, or fully recycled, making pallets one of the most successfully recycled wood products in the entire world. This creates a massive hidden industry. Huge pallet repair factories, crushing mills, chipping plants, and recycling centers that turn broken wood into mulch, biofuel, animal bedding, and even new engineered wood boards. Today, we're stepping inside America's supergiant pallet recycling plants, where millions of broken pallets are collected, sorted, rebuilt, and transformed in a mind-blowing industrial process that keeps the country moving and saves millions of trees every year. Before we dive in, don't forget to like, subscribe, and turn on the notification bell so you never miss our deep dive documentaries. Wooden pallets might seem simple, but without them, modern supply chains would collapse. In the US alone, pallets carry nearly 80% of all transported goods. From Amazon packages to construction materials, they support over $400 billion worth of products every single day. A typical pallet weighs 30 to 50 pounds and is built from low-grade lumber. Wood that's unsuitable for furniture but perfect for strong, durable shipping platforms. Because this type of wood is cheap and abundant, pallets became the global shipping standard during World War II. Today, they are so essential that the US maintains a continuous cycle of manufacturing, repairing, and recycling more than 1.8 billion pallets at any given moment. But pallets don't last forever. Forklifts break boards, nails loosen, heavy loads crack the frames. Every year, nearly 500 million pallets become damaged. But instead of throwing them away, America recycles them. Why? Because pallets are incredibly recyclable. A pallet can be repaired and reused up to 10 or even 15 times. And when it can no longer be repaired, the wood can be ground into mulch, compressed into fuel pellets, used for animal bedding, turned into particle board, or processed into biomass energy. The journey begins far from the recycling plant. In thousands of warehouses, distribution centers, factories, grocery stores, and construction sites across the country. Whenever pallets become damaged or no longer meet quality standards, companies stack them in designated pallet return zones. Recycling plants send trucks daily to collect these mountains of pallets. Some distribution hubs return 10,000 to 20,000 pallets per week. Major retailers like Walmart, Home Depot, and Costco return even more. Large pallet companies operate fleets of semi-trucks that pick up damaged pallets from multiple locations and bring them to regional recycling yards. Once the pallets arrive, the first phase begins: sorting. Workers in forklifts unload giant stacks, sometimes up to 18 feet tall. Every pallet is examined for damage: broken deck boards, cracked stringers, missing nails, or warped frames. Sorting is done at lightning speed. Workers process up to 700 pallets per hour using automated conveyor lines, tipping tables, and pallet stackers that lift, rotate, and align pallets with incredible efficiency. The plant's goal is simple: recover as many pallets as possible for reuse, because repairing generates much more value than grinding. Once sorted, the repairable pallets move to the next stage: an industrial repair line where carpenters, machines, and nail guns bring them back to life. Repairing pallets is one of the most impressive parts of the entire industry. The plant looks like a cross between a carpentry shop and a high-speed assembly line. Skilled workers wearing gloves, ear protection, and steel-toe boots work alongside pneumatic tools and automated machines. The pace is fast. Each worker repairs 150 to 250 pallets per shift, and large plants handle tens of thousands per week. The moment a pallet reaches the repair line, it undergoes a systematic evaluation. Workers quickly identify broken deck boards, split stringers, or missing nails. Many pallets can be fixed in less than a minute. Workers use a tool called a pallet pry bar to pop off broken boards. For broken stringers, the plant may use a specialized saw to remove the damaged section. Nearby, automated saw lines cut thousands of new deck boards per hour from raw lumber. The boards are fed onto conveyors that send them straight to the repair stations. Workers use pneumatic nail guns capable of firing 3 nails per second. They attach new boards to the pallet frame, ensuring perfect spacing and alignment. Nails are applied with consistent depth and pressure, maintaining pallet strength standards. If a pallet stringer is cracked but still salvageable, repairers attach a component called a companion stringer. A strong piece of wood that strengthens the structure and extends the pallet's lifespan by several more cycles. Every repaired pallet is inspected. If it fails any structural test, loose boards, misaligned nails, gaps, it goes back for further repair. The result? A pallet that looks almost new and can support 2,500 to 3,000 pounds of product. At large facilities, repaired pallets immediately move to heat-treating chambers. Many industries, especially food and pharmaceuticals, require pallets to be heat-treated to eliminate pests and bacteria. Pallets are heated to 56 degrees for 30 minutes, monitored by digital sensors. Once heat-treated, pallets are stacked into perfect towers of 20 to 25 and banded for delivery. These, like new pallets, are sent back to retailers, warehouses, and factories, ready for another round of heavy-duty service. But not all pallets can be saved. Those that are too broken or unsafe for reuse head to a completely different part of the plant, the grinding and recycling zone. The grinding zone is where industrial power truly shows itself. Here, the sound of roaring motors fills the air as giant machines reduce mountains of broken pallets into useful secondary products. Trucks and forklifts dump unusable pallets into massive piles. These stacks can reach 20 to 30 feet high. Pallets are fed by an excavator or conveyor. As they enter the grinding chamber, spinning teeth tear them apart. Nails and metal fragments are automatically removed by a magnetic separator and collected for recycling. The biggest pallet recycling plants in America operate almost like automotive factories. Everything is automated, coordinated, and streamlined for maximum efficiency. Robotic stackers lift finished pallets, align them, and pack them onto trailers. Automated conveyors deliver boards and pallet frames to repair stations. Computer systems track each pallet, its repairs, and its quality rating. Some facilities even use AI-based vision systems to scan pallets for damage. These systems instantly detect broken boards, missing nails, and structural weaknesses, guiding workers on what to repair. Every truck entering or leaving is weighed. Every pallet is tracked. Every board cut is optimized so that no wood is wasted. This level of efficiency is what makes pallet recycling more profitable and more environmentally friendly than manufacturing new pallets. If you enjoyed this deep dive into the hidden world of pallet recycling, make sure to like, subscribe, and hit the bell so you never miss the next incredible journey into the factories and farms that power our modern world. Thanks for watching, and stay curious.
Every year, the global wood industry processes more than 4 billion cubic meters of timber, producing enormous volumes of lumber for construction, furniture, and paper. In fact, in modern wood processing industries, more than 95% of wood waste is reused or recycled. What once looked like useless dust is now turned into energy, engineered wood, fuel pellets, fertilizers, and even advanced biomaterials. Today, we're stepping inside the supergiant sawdust recycling industry, where mountains of wood waste are transformed into valuable resources that power factories, heat homes, and build new products across the world. Before we dive in, don't forget to like, subscribe, and turn on the notification bell so you never miss our deep dive documentaries into the hidden industries that power the modern world. To understand this industry, we first need to understand where all that sawdust comes from. In a typical sawmill, only about 50 to 60% of a log becomes finished lumber. The rest turns into byproducts: sawdust from cutting, wood chips from trimming, bark removed from logs, and small offcuts that cannot be turned into boards. Multiply this by thousands of sawmills and furniture factories operating every day, and the scale becomes enormous. A single large sawmill can generate 200 to 400 tons of wood residues every day. Across the United States and Canada alone, the wood industry produces tens of millions of tons of sawdust and wood chips each year. Instead of throwing this material away, modern facilities capture it using powerful extraction systems. Another rapidly growing sector uses sawdust to produce wood pellets, one of the fastest growing renewable energy fuels in the world. Wood pellets are small cylindrical fuel units made by compressing dry sawdust under extremely high pressure. The process begins by grinding wood waste into uniform particles. The material is then forced through metal dies in powerful pellet mills. As the sawdust passes through the dies, friction generates heat that softens natural lignin in the wood. This lignin acts as a natural glue, binding the particles together without additional chemicals. The pellets emerge as dense cylinders roughly the size of a pencil eraser. After cooling and screening, they are ready for use as fuel. Wood pellets are incredibly energy dense and burn efficiently, producing far less smoke and ash than raw wood. Because they are made from recycled sawdust, they represent a renewable energy source that reduces dependence on fossil fuels. Today, the global pellet industry produces more than 40 million tons of pellets every year, and demand continues to grow as countries search for cleaner energy alternatives. In many regions, sawdust also becomes the fuel that powers the very factories that produce it. Biomass boilers use wood waste to generate heat and steam for industrial processes. Inside these systems, conveyor belts feed sawdust into combustion chambers where it burns at high temperatures. The heat produces steam that drives turbines or heats kilns used for drying lumber. Some sawmills generate enough electricity from their wood waste to power entire operations and even supply excess energy to local grids. Another major destination for sawdust is agriculture. Farmers have long used wood shavings and sawdust as animal bedding because the material is soft, absorbent, and inexpensive. Dairy farms, horse stables, and poultry operations rely on these materials to keep animals dry and comfortable. After use, the bedding is often composted and returned to fields as organic fertilizer, completing a natural recycling cycle. Wood chips and bark, meanwhile, are widely used in landscaping and soil improvement. Municipal recycling programs collect tree trimmings and wood debris from cities, grind them into mulch, and distribute the material for use in parks, gardens, and erosion control projects. Mulch helps retain soil moisture, regulate temperature, and prevent weeds from growing. This simple use of recycled wood waste plays a surprisingly important role in urban environmental management. In recent years, scientists have discovered even more innovative uses for sawdust. Researchers are developing biomaterials that transform wood waste into high-performance products. One example is wood plastic composite, a material created by combining recycled wood fibers with recycled plastics. These composites are used to manufacture outdoor decking, fences, and construction materials that are durable and resistant to moisture. Another emerging technology converts sawdust into biochar, a carbon-rich material produced through controlled heating in low-oxygen environments. Biochar can improve soil fertility and capture carbon, helping reduce greenhouse gas emissions. Other experiments are exploring how wood fibers can be used to create biodegradable plastics, insulation materials, and even advanced textiles. The reason sawdust can be recycled into so many products lies in the unique structure of wood itself. Wood fibers are composed primarily of cellulose, hemicellulose, and lignin, natural polymers that provide strength and flexibility. These fibers retain their useful properties even after the wood is cut, ground, or processed. This makes wood waste one of the most versatile recyclable materials available. Behind the scenes of this industry are massive logistics networks that move wood residues from mills to recycling facilities. Conveyor belts hundreds of meters long carry sawdust between processing stages. Front-end loaders move giant piles of wood chips across storage yards. Automated systems monitor moisture content, particle size, and energy output to ensure consistent quality. Some of the largest wood recycling plants operate around the clock, processing thousands of tons of material every day. Giant hammer mills shred wood waste into uniform particles. Magnetic separators remove stray metal fragments like nails or screws. Screening machines sort particles by size, directing them toward pellet production, engineered wood manufacturing, or energy generation. What makes the sawdust recycling industry particularly remarkable is its efficiency. In many modern sawmills, nearly every part of a tree is used. High-quality lumber becomes building materials. Smaller pieces become furniture components. Wood chips become paper pulp. Bark becomes mulch. Sawdust becomes pellets, boards, or biomaterials. Very little goes to waste. This efficiency reflects a long history of innovation in the forestry sector. In the early days of industrial logging, sawdust was often considered a nuisance. Sawmills dumped it into rivers or burned it in open piles. Over time, environmental concerns and rising resource costs forced the industry to find better solutions. By the late 20th century, wood waste had become too valuable to ignore. Today, the sawdust recycling economy supports thousands of jobs and generates billions of dollars in economic activity. It also helps reduce pressure on forests by ensuring that harvested trees are used as efficiently as possible. By transforming waste into resources, this industry demonstrates how circular economies can work in practice. The next time you see a piece of furniture, a bag of wood pellets, or even a landscaped garden bed, there is a good chance that the material began as sawdust. What once looked like nothing more than dust from a saw blade is now an essential raw material powering industries around the world. From giant sawmills to advanced recycling plants, the journey of sawdust shows how innovation can turn waste into opportunity. In the supergiant sawdust recycling industry, mountains of wood dust are quietly transformed into energy, materials, and sustainable solutions that help power the modern world. If you enjoyed this deep dive into the hidden world of wood recycling, make sure to like, subscribe, and hit the notification bell so you never miss our next journey into the incredible industries that shape the materials around us. Thanks for watching, and stay curious.